Hey everyone, some of you have asked if I can do some videos just to preview what's to come after spring break. So what I'm going to be doing is these next set of videos are going to be basically my lessons for the last 2 or 3 classes before we do that entire month-long review thing for AP Calc. And so this is completely optional. If you want to watch and just to get ready for what's to come, go ahead. And if you don't, that's totally fine. It's spring break, so just make sure you're well rested because May is going to be a really difficult time for most of you guys. It'll be kind of hectic. But anyways, let's get into this. The idea for the last section of this course is how to solve differential equations, where we have something like dy over dx is equal to some sort of function mixed with an x and a y. This is very similar to when we were drawing slope fields before the start of spring break. Now, a couple of things I want to touch on here is I'm not going to explain some of the rudimentary rules of why something works and why something exists. That will be explained in class, but let's go right into it. So we have something like dy over dx is equal to 8x over 3y squared. And we have f of 0 is equal to 2. But if we look at the question, it says, please go ahead and solve for f of x. Which, just like in grade 9, 10, and 11, and 12, it's basically saying find the function f of x such that it satisfies both of these things. Now, the first basic rule is you want to make sure the dy's and the dx's are both on top. And the second thing you need to know is that both the x's and the y's have to be with their respective dx's or dy's. So what I'm going to do here, and this technically... well, I won't really explain why this works, but what you want to be doing is, I'm going to be taking this over here. Okay. I'm going to multiply both sides by dx. Okay. Because when I do that, the dx's cancel each other out, and we have dy is equal to 8x dx over 3y squared. Once again, I'll actually go through a comprehensive explanation of why this actually can work, but because you guys are watching this video online, it's not going to be, it's not going to make a lot of sense. So once we have this, I'm going to erase this part over here. We're going to do the exact same thing, and we're going to multiply both sides by 3y squared. These two cancel out, and now we are left with this function, and I'm going to write this one more time. 3y squared dy is equal to 8x dx. And so in class, like I said before, whenever you had a dy mixed with a y function and a dx mixed with an x function, or any d of any letter mixed with that exact same letter function, what we're going to be doing is we're going to integrate both sides. So now I have the integral of 3y squared dy is equal to the integral of 8x dx. We're going to be moving up here, and it's important to note that we have an indefinite integral. There are no bounds, and if there are no bounds, that means we have to add a c or some sort of constant at the end of both of these respective integrals. When I integrate this, I have 3y cubed over 3 plus c, and on this side, I have 8x squared over 2 plus, now in this case, I'm going to add a d, because it's important to know that both of these functions are different numbers. In saying that, though, if you wanted to write both as c's, that's completely fine because of what I'm going to do next. I'm going to clean this up. This is y cubed plus some sort of constant is equal to 4x squared plus some sort of constant. My main goal is to find f of x. So before I do anything else, let me move these two to one side. I don't know what both of these constants are. This could be a 3, this could be a 5, or it could be any other constant. But I know that if I subtract c on both sides, if I minus c on both sides, I have y cubed is equal to 4x squared plus another constant. Okay? I don't know if it's 2 times c or 3 times d. I just know that if I combine these two together and move them to one side, it's going to be another constant. So for the sake of not adding too many variables, I'm just going to say I'm adding c. Okay. Now, let's go ahead and use this. F of 0 is equal to 2, so when I plug 0 into x, my y value is 2. So 2 cubed is equal to 4, 0 squared plus c. I have 8 is equal to c, because this whole thing is gone. Okay. Now there's going to be quite a bit of stuff I have to erase, so let me go ahead and do that over here. Once I figured out what my constant is, I take this function over here, and instead of writing c, I already know my c is equal to 8. So I'm going to erase this, and this is 8. And it all comes back to our final, or the thing that we have to do, which is we have to solve for f of x. So f of x or y, right now I have y cubed is equal to all this. So in order for me to solve, I have to cube both sides. So y is equal to the cube root of 4x squared plus 8. And that is my final answer. Now, it gets a little bit trickier, and this usually stumps students when it's on the AP exam, because they do all that work and they forget to check for certain questions. So what I mean by that is, well, let's go over this over here. dy over dx minus 6x over y is equal to 0, and I know that f of 1 is equal to negative 2. First thing I'm going to be doing is I'm going to add 6x over y onto both sides. So 6x over y. Next, I'm going to multiply by dx on both sides. So these cancel out. And then in doing so, I can also multiply both sides by, oh, sorry, this should be y. But I can multiply both sides by y, because these two cancel out. Once I have that down, I have a new function of y. dy is equal to 6x dx. We are satisfied with this so far because all the y functions are paired up with the dys are on top. And all the x functions are paired up with the dx on top. So now we integrate. This is y squared over 2 plus c is equal to 6x squared over 2 plus d. Okay. We can start to simplify a little. Y squared over 2 plus c is equal to 3x squared plus d. And now I'm just going to move everything to one side, or I'm going to move the c to the other side. So we have y squared over 2 is equal to 3x squared plus c again, knowing that even though we're not saying that c plus c is equal to d, but we're just making a generic constant because I don't know what c is and I don't know what d is. At this point, I'm going to multiply, well, you can multiply both sides by 2 if you want, or you can go ahead and plug in the 1 and the negative 2. Okay? It's completely up to you. So some people like to go like this, and then plug in the 1 and the negative 2. But others, because they don't want to waste time, they plug the 1 and the negative 2 in right away, which is what I'm going to be doing. Negative 2 squared over 2 is equal to 3 times 1 squared plus c. This is 4, but 4 divided by 2 is 2. 2 is equal to 3 plus c. Eventually, you get negative 1 is equal to c. Now that we have this, let me go ahead and erase some of the stuff. Remember, you can pause and rewind and rewatch some of this. So if I'm going too fast, you can always just review it again. Y squared over 2 is equal to 3x squared minus 1, since c is negative 1. And now I'm going to multiply both sides by 2. So y squared is equal to 6x squared minus 2. And all we need to do now is remember that our goal is to figure out what f of x is. So in order to get x by itself, we have to square root both sides. And y is equal to the square root of 6x squared minus 2. Knowing that there are actually two possible solutions. For those in my class in the last 2 years, you know that if I ever square root an even function, I always get a positive or a negative. Okay? Or when I even root a function, sorry, I get a positive and a negative. There. And a lot of you might be tempted to say, oh, well, you know what? Both answers work. Y is equal to 6x squared minus 2, and y is equal to the square root of 6x squared minus 2, negative. Sorry, let me put this here. Negative root, whatever I just said. But it's important for you to understand that you need to check. Over here, if I plug in 1 into the x, I get y is equal to the square root of 6 minus 2, y is equal to the square root of 4, y is equal to 2. But this completely contradicts what we're trying to be what we're given. If I plug in 1, I should get negative 2. But clearly, I only get 2 here, which means this function is not our solution. Whereas if we plug in 1 into the x, y is equal to negative square root of 6 minus 2, y is equal to negative root 4, and y is equal to negative 2. This is exactly what we want, meaning our only solution function is this. Some of you might be wondering, well, why did we not check for this over here? And to be honest, you could check if you want, but because I took the cube root of something, I know that I don't have to check, because there's not a solution that won't work if you have an odd root, whether it's 3, 5, or 7, right? You're only going to, like, this is always going to work. Whereas if you have an even function over here, you need to understand that there's a positive and a negative, and you're going to have to double check. Let's get to something a little bit harder, but not too bad. We have y primed is equal to 2xy squared. Well, instead of writing y primed, this is actually dy over dx, and that's equal to 2x y squared. I'm going to multiply both sides by dx. So I get dy is equal to 2x y squared dy, but then I'm going to divide both sides, or multiply both sides by 1 over y squared. These two naturally cancel out, and you get dy over y squared is equal to 2x dx. The reason I'm doing this is because I want all my x terms with the dx and all my y terms with the dy. Knowing once again, both the dy's and the dx's have to be on top. So you can't just take this and move it to the bottom. Okay, dy and dx's have to be on top. I will explain that in class a little bit more, but for now, we're just going to roll with it as this is more of a preview. Let's go ahead and integrate. So I have technically y to the negative 2 dy, and that's equal to 2x dx. Let me integrate over here. We get y to the negative 1 over negative 1 plus c is equal to 2x squared over 2 plus d. 1 over negative y plus, is equal to x squared plus c. Again, if you like, you can kind of isolate all this so that makes a little bit more sense, but for now, I'm just going to multiply or plug in 2 and negative 1. So 1 over negative 1 is equal to 2 squared plus c. Let me erase some of this stuff so I have a little bit more room. Oop, maybe not that. And let's go over here on the left. 1 is equal to 4 plus c, where c is actually equal to negative 3. So if we have that, c is equal to negative 3, let me erase this now, and this, take this over here. 1 over negative y is equal to x squared minus c. But x squared plus c, sorry, x squared minus 3. I'm going to multiply both sides by negative y. So 1 is equal to negative x squared y plus 3y. Actually, what I'm going to do here, just to make it a little bit less confusing, 1 is equal to x squared minus 3 times negative y. There. Divide both sides by x squared minus 3. So 1 over x squared minus 3 is equal to negative y. And finally, just multiply both sides by negative 1. So your final answer is, let me just move over to the left over here, negative 1 over x squared minus 3 is equal to y. Or if you want to write it, f of x. Alrighty, let's get to something just a little bit harder over here. Number 4. We have xy primed minus 4 is equal to y squared. So the first thing I'm going to do, x dy over dx minus 4 is equal to y squared. I'm going to add 4 onto both sides, so x dy over dx is equal to y squared minus 4. I'm going to treat this as one term. I'm going to multiply both sides by dx. So these cancel out, meaning I have x dy is equal to y squared minus 4 dx. I'm going to times both sides by 1 over dy. Oh, sorry, no. 1 over x. So these cancel out. I have dy is equal to y squared minus 4 dx over x. And then for the last thing I'm going to do is I'm going to multiply by 1 over y squared minus 4 onto both sides. These cancel out. And in doing that, let's go to the top. I now have dy over y squared minus 4 is equal to dx over x. Okay. So I'm going to erase most of the stuff here just so we have a little bit more room. Now we integrate. I'm going to change this as 1 over y squared minus 2 squared dy is equal to 1 over x dx. Because you're supposed to realize here that this is a special antiderivative. This gives us 1 over 2 tangent inverse of y over 2 plus c and equals to ln of the absolute value of x plus d. Now, if you're getting tired of writing so many constant variables, you can just write the plus c right away without writing any constant here. Let's go ahead and use our givens. If I plug in 1, I get 0. So, let's see. 1 over 2 tangent inverse of 0, because 0 divided by 2 is 0, is equal to the ln absolute value of 1 plus c. Ln of 1 is 0 as well, so we can go ahead and just eliminate that. Okay. I'm going to multiply by 2 on both sides, so I get tangent inverse of 0 is equal to 2c. The tangent inverse of 0 is 0, so 0 is equal to 2c, meaning, well, c is equal to 0. Okay, so once we have that, let me erase most of this stuff. Let me get rid of this, and we're going to take this as, oops, this is what we really want. Okay, c is equal to 0. Going to get rid of that because c is 0. Now, 1 over 2 times 2 on both sides, tangent inverse of y over 2 is equal to 2 ln absolute value of x. Okay. In order to eliminate my inverse, what I'm going to do is I'm just going to tangent both sides. Take the tangent of both sides. So these two cancel. I get y over 2 is equal to the tangent of 2 ln the absolute value of x. And then multiply both sides by 2. Y, or if you want to call it f of x, is equal to 2 tangent 2 ln absolute value of x. This is how we solve something a little bit more complex. Still doable, but takes a little bit more time. We're going to add to the difficulty by doing something like this. So we have dy over dx is equal to 2xy plus 2x. I'm going to first factor out the 2x on the right side. So I have 2x and y plus 1. Treat this as a term. Then, after multiplying and dividing, you should now be able to get this with ease. dy over y plus 1 is equal to 2x over dx. Let's go ahead and integrate both sides. And when we do, it should be dx on the top. But when we integrate both sides, we end up getting ln of the absolute value of y plus 1 is equal to x squared plus c. Now, this is extremely important because this is the first time we've seen an absolute value of ln where the inside is a y function. Whereas the one we did previously, we had the absolute value of ln x, or ln of the absolute value of x, but that was the x term. Because we're trying to isolate the y term, things are a little bit more difficult now. Okay, let me just get rid of this random 2. So what I'm going to do is I'm going to write this as an exponential form. We have e to the x squared plus c is actually equal to the absolute value of y plus 1. From what we learned before, because we have the absolute value of y plus 1 in grade 11 and 12, we know that this could go one of both ways. This could be a positive answer or a negative answer, and I'm not sure which one it is. Okay, you don't have to guess, but we're going to do something a little bit smart here. Whenever we have x squared plus c in the exponent, this is the same thing as e to the x squared times e to the c is equal to y plus 1 absolute valued. Okay, get rid of this. I don't know what that's from. Now, over here, this is a constant. So if we have a constant mixed with another plus minus, that's still going to be a constant. And because we've used c already, I'm just going to use a. So I'm going to rewrite this as the plus minus of e to the c times e to the x squared is equal to y plus 1 absolute valued. I don't know which one it is, but because I can call this whole thing a constant, whatever one we actually have is going to make it right. And I'll explain this a lot more in person, but basically what I'm doing is a e to the x squared is equal to y plus 1. I know this is a little bit confusing, but from now on, just know that if you ever have some sort of plus minus constant, you get rid of the absolute value for your long questions. So we have this. I forgot to write. We are trying to find f of 0 is equal to 6. So let's go ahead and put this here. Copy and paste. A e to the 0 squared is equal to 6 plus 1. Anything to the 0 is going to be 1, so a is equal to 7. So now 7e to the x squared is equal to y plus 1, minus 1 on both sides. 7e to the x squared minus 1 is equal to y, and that is your answer. Let's do one final one, something just a tiny bit harder. Let's go with number 6. We have dy over dx is equal to 2 plus y over x. And f of -1 is equal to 3. dy over 2 plus y is equal to dx over x. Let's integrate both sides. So we have ln of the absolute value of y plus 2 is equal to ln of the absolute value of x plus c. Note that I don't actually care about the absolute value of x over here because we're not trying to isolate x. We are trying to get y by itself. I'm going to e both sides. E to the ln of the absolute value of x plus c is equal to the absolute value of y plus 2. Now, I don't know if we're looking for a positive or a negative solution over here, so I'm going to rewrite this as the plus minus of e to the c times e to the ln of the absolute value of x. And that's equal to y plus 2. Because this whole thing tells us that it could be positive or negative, we don't need to put the absolute value on the right side anymore. So I'm going to get rid of this. I'm going to call this whole thing a, which is just another constant. Okay. Now, if I plug in -1, I get 3. So a of e to the ln -1, oops, maybe I'll write that a little bit nicer, sorry about that, is equal to 3 plus 2. The absolute value of -1 is 1. Ln of 1 is 0. So a to the 0 is just a. A is equal to 5. Now that we have this, take this equation over here. 5e to the ln of the absolute value of x is equal to y plus 2. 5e to the ln of the absolute value of x minus 2 is equal to y. And there you have it. Now we're going to go to our second last topic, and this is the idea of proportional rates of change, namely exponential growth and decay modeling. So let's look at this definition. Okay, sorry about that. The rate of change of a quantity y is proportional to the amount of the quantity at that instance. And you're usually given the equation dy over dx is equal to k times y, where k is the proportional constant. Now let me just break this down to what it actually means. Some quantity of y is changing. Y can be the amount of money you have in your bank, the area of some sort of thing you're trying to calculate, or the volume of something you're calculating. And depending on how much of that item or that quantity of that item is present right now, it completely alters how much the rate of change of that item is increasing or decreasing by. Now, if you're still not really understanding that, here's what I mean. Imagine you have a snowball at the top of a cliff, right? So you're just rolling a snowball over here. Now, because it's going to gradually pick up the excess snow, it's getting bigger and bigger and bigger. And at the very beginning, the rate of change of that snowball is quite little because there's only a little bit of snow for you to roll around. So there's a little bit of surface area for you to contact whatever snow is currently around it. But as you're going bigger and bigger and bigger and bigger and bigger, you have more surface area and you're going to pick up a lot more volume. So then the snowball's really, really big. And this is basically the idea of what we're trying to say with exponential growth and decay modeling, where we're trying to find this k constant that allows us basically to approach just how fast we are actually increasing or decreasing by, depending on that type of question. So let's go ahead and integrate this. Because k is a constant, what eventually you should get is dy over y is equal to k dx. I'm going to integrate both sides, just like we've been doing before. We get ln of the absolute value of y is equal to kx. And remember, because we're absolute valuing y, yeah, that makes sense. We're going to plus c. We're going to go ahead and just make it so it's an exponential function now. E to the kx plus c is equal to the absolute value of y. Now, I don't know whether it's positive or negative, so what I'm going to be doing is I'm going to say this is the plus minus of e to the c times e to the kx is equal to y absolute valued. And because I don't know if it's positive or minus, let me get rid of the absolute value sign and just replace this with a. Your generic function is y is equal to a to the e to the kx, a times e to the kx. For all these basic exponential growth and decay modeling functions, you get y is equal to a times e to the kx. You need to know how to prove this, though. So I would basically recommend the first time you're doing this to keep proving and to keep going, starting from scratch until you really have that foundation down. And even on a written question on an AP exam, I would still write this, like write all the steps over here. It takes like maybe 3 seconds, but it shows that you understand the work. And if you get the final answer wrong, depending on how the question is marked, you might still get part marks for this. Now, the question says that SM-151, which is a radioactive substance, decays at a rate proportional to the amount of the remaining substance. So SM-151 has a half-life of 90 years. How long will it take for 200 grams of SM-151 to decay to 1 gram? What we're looking at is this. Depending on the time and the amount of stuff left at a current time, as more time passes, we're looking at a different type of decaying rate, whether it's more decaying in the beginning and less decaying in the end. It's usually what it means when it has half-life. So we decay by a lot in the very beginning because there's a bunch. The first 90 years, you're going to decay by 100 grams. But the second 90 years, you only get decay by 50, and then 25, and then 12.5, and so on, and so on, and so on. So we have dy over dt is equal to k times y. We're not doing dx this time because we're changing at a rate of a time, or based off of the rate of change of time. So let's go ahead and integrate this. You can already assume that y is equal to a to the e, a times e to the k t, or a times e to the k t right now if you want. Or you can just do the whole thing again because we're using a different variable. So I'm just going to go ahead and do that. dy over y is equal to k times dt. I'm going to integrate both sides. I have ln of the absolute value of y is equal to kt plus c. E to the kt plus c is equal to the absolute value of y, knowing that full well plus minus e to the c times e to the kt is equal to the absolute value of y. I'm going to go ahead and change this absolute value sign and make this whole thing an a. So y is equal to a times e to the kt. Now let's look at this question again. We know that when time is 0, we have 200 grams of SN151 because we start with 200 grams. So that's the first thing we're given. When t is equal to 0, we know that we have 200 grams. Let's go ahead and solve this over here. A e to the k times 0 is equal to 200, which means a is equal to 200. Our equation now is 200 e to the kt is equal to y. Next, we know there's a half-life of 90 years. So at 90 years, our y value is 100. Now let's go ahead and plug things in. 200 times e to the 90k is equal to 100. I'm going to divide both sides by 200 because e to the 90k is equal to 1 over 2. I'm going to ln both sides, so 90k is equal to ln of 1 over 2. And now just divide both sides by 90. So k is equal to ln of 1 over 2 over 90. So now we have our k constant. Once again, plug in all we know using this. Oh, sorry, let me just get rid of, whoa. Okay, that's weird. Sorry, something's going on here. Okay, yeah. We have a, we have k, so 200 e to the ln of 1 over 2 over 90 times t is equal to y. Find the time that it takes for 200 to decay to 1 gram. So we don't know what time is, that's what we're trying to find, but we know y is equal to 1. All we have to do is, well, plug in 1. 200 e to the ln 1 over 2 over 90 times t is equal to 1. E to the ln 1 over 2 over 90 times t is equal to 1 over 200. You're going to ln both sides. So if you ln both sides, ln of 1 over 2 over 90 times t is equal to ln of 1 over 200. In order for you to isolate your t, well, just divide both sides by whatever this garbage is. Your time is equal to ln of 1 over 200 divided by ln of 1 over 2 over 90. If you plug this into your calculator, or just leave it like this if it's a written question, your answer should be 687.947 years. Typically, they only want 1 or 2 decimal places, but if they don't say, more is usually better. But they typically say.